This is radicals simplifying with roots of 3 or more. So we're rationalizing the denominator here. But before we would just go, oh, square root of whatever it is. But we can't now because they have to be the same. Remember, whenever we multiply, the roots have to be the same. So here we have to use a cube root. And we're also looking at how many x's do we need in order to get them out of the root. Well, we need 3. That's what we need. You need 3, and we only have 1. So that means we need 2 more. So if we multiply x squared top and bottom, then on the top we would get the cube root of x squared, because that's all you get with times 1. And then now that we have the same root, we can put them all under the same, and we'd have 1 and 2. And that gives us the 3 that we need to take it out. So cube and cube root, they would cancel, and leave us with just x. And that's our answer. No more radical on the denominator. It's all gone. So if we did this one, we'd use a 5th root. But we have 2, which means we need 3. 2 plus 3 is 5. And so on the top, we would get the 5th root of x cubed. And on the bottom, we now have the 5 that we need to take one of them out. So this would become 5th root of x squared times x cubed, which is the 5th root of x to the 5. And they cancel to give us just x. Okay? So what would we need here? So we need a 7th root. And we already have 6, which means we only need 1 more. So that's a 7th root of x over, and now we would have x7 to leave us with just x. So again, this would be x6 times x, which is x to the 7, because 6 plus 1 is 7. And then they cancel and leave us with just x. And that's all you have to do for each of these. So when you see the denominator with a radical, just give it what it needs. It has to be the same root, and you give it the number that it would need to make that number. Okay, so let's try them all together now. So we have our checklist. Number 1, we need to simplify the fraction. Number 2, we need to simplify the radical. And then number 3, we have to rationalize. We always save that to the end. So we look at our radical. There's no fractions that will cancel. We now look at the radical, the cube root. And do we have any groups of 3? Yes, right there. So we're going to split this up. Cube root of x over cube root of 8y squared, which is cube root of 2 times 2 times 2 and y squared. So we circle our group of 2's, and we can take 1 out, because there's one set of 3, and that's it, which would leave us with 2, and then the cube root of y squared. We can place that back into the problem. So if cube root of x over 2 cube root of y squared. Now everything would be done. Part 1's done. Part 2 is done. Nothing can cancel in the radicals. There's all the groups have been taken out. So all we have left is to rationalize. So we multiply this by cube root, top and bottom. We already have 2 y's, so we just need 1 more. Alright, we'll bring it down here. I don't want to use a circle. Here. So we now have on the top cube root of xy, and on the bottom we have a 2. And then remember the y2 and y, that's now 3, so we end up with just the 1y. Each time that's all that's happening. See, once we get the x6, x7, it's enough to cancel. So here we'd have y3, and a cube root, they cancel to leave us just y. And now we're rationalized. Go through our checklist, simplify the fraction, nothing cancels, that's inside and outside, can't cancel them. Radical, there's no groups of 3, so that's done. And rationalize, there's no rational in the denominator. It's perfect. Alright, so next one. Fraction. Can we cancel fractions? Yes, we can. that one, and that one. And then also these are both fourth roots, which means we have one giant root here. So we can cancel them. That x cancels, and we're left with x squared inside. So let's rewrite it. This now means that we have a 1 and a fourth root of 1. So that's just 1. And on the bottom we have a 2 and then a fourth root of x squared. Okay, go to the radical. There's not enough pairs to take it out. So 1 and 2 are done. Part 3, rationalize. So we have to multiply by a fourth root. And since we already have 2, we just need 2 more. So on top we have fourth root of x squared. And on the bottom we have 2. And now we have 4 to take out and make 1. And that's it. So that's rationalizing the denominator with roots more than 2.